Most welcome to the 7 Science Theater at gmail.com. That's how you can contact us. Today we're going to teach you thyroid gland and its hormones. Okay, the 7 Science Theater, you like? You like? You subscribe for more and better videos. Share to all other students to also enjoy the information in here and the knowledge and the wisdom. Don't be mean, share it out. Structure and size variation of the thyroid gland. Thyroid gland, I will talk about its histology in a short time. You have the connective tissue, you have the acinar cells, or what you can call the follicular cells. You have the colloid in the center. This is secreted by the acinar cells. You have parafollicular cells, which are responsible for secreting calcitonin. Then we have capillary, blood capillary, just a blood vessel. We have basement membrane, onto which the follicular cells are attached. So when the thyroid gland is moderately active, you can see the cells are short and the colloid is larger. When it is highly active, the colloid is less and the cells are long. Colloid is less because the gland is performing its activity of secreting the thyroid hormones. When it is inactive, the cells are very flat and the colloid is too much because these cells are secreting much of the colloid. As they secrete much of the colloid, this colloid is stored and the cells remain inactive. Elongation of cells occurs when they are active. Okay. Thyroid hormones. We have thyroxine, or you can call it T4, 3,5, 3' 5' tetraiodothyronine. And we have T3, or you can call triiodothyronine. T3,5, 3' triiodothyronine. Okay. We have the reverse triiodothyronine, where we have 3', 5'. Here it was 3, 5, 3'. Here it is 3, there is no 5. 3, 3', 5'. Okay, triiodothyronine. That is reverse. Or you can call it RT3, inactive thyronine. It is inactive. Calcitonin is also from the thyroid gland and is a hormone secreted by parafollicular cells of thyroid gland that one is concerned with homeostasis of calcium. Steps in synthesis. One is iodine trapping. Iodine is trapped. We shall look at a diagram which is coming. Let's first go there and see it. Look at this. When they are synthesizing the thyroid hormones, we shall have we have iodine in blood, call it a capillary. This iodine will enter through a sodium iodine symporter. So this one requires energy for transport of sodium, and that movement of sodium causes movement of iodine inside. That is sodium iodine symporter. And as iodine enters, now this is a single follicular cell or acinar cell or epithelial cell. It secretes it. The iodine moves through the cytosol and it goes to the apical membrane. This is the basal membrane where we had the basement membrane. So this is the basal surface, this is the apical surface. So now this very cell synthesizes the thyroglobulin, which is formed in the rough endoplasmic reticulum. This is a protein, so ribosomes are involved. It is formed, cleaved in the Golgi, and the formed protein Tg goes to the apical surface, thyroglobulin. Now, the pendrin, this one, pendrin, pumps the iodide ions into the colloid. In the colloid, the iodide in the colloid there is an enzyme called peroxidase, which oxidizes the iodide ions to oxidize the iodide ions. So this, you can see, it is like a radical. So this one combines with the TG, thyroglobulin. Now the thyroglobulin is a protein which has numerous tyrosine residues. Yeah, there are very many. We shall see the number around 141 if I'm sorry. So the iodine attaches to tyrosine residues. So now we can have one iodide attaching to one tyrosine. It forms a monoiodothyronine. Yes, MIT. If there are two, it forms a diiodothyronine. Yes. Now, after attaching this iodine to thyroglobulin, we shall have formation of a thyroglobulin, which has several, like it has this process called coupling, where you can have MIT combined with another MIT to form, you can have MIT combined with a DIT to form a T3, triiodothyronine. Or you can have DIT combined with a DIT to form tetraiodothyronine. Yes, that is coupling. Step 5. Now, the TG in the colloid now is reabsorbed into the epithelial cell. So this reabsorption will involve formation of a pseudopodium, or you can see there's just exocytosis. Yeah, it is taken into the epithelial cell and traverses through the cytosol to the basal surface, and at the basal surface the droplets of colloid will combine with lysosome, and the proteases there will cleave off the hormones here, and thyroglobulin will be left apart, and the cycle restarts. So the T3 and T4 will enter the blood. Yeah, that is it. That is the step 10. So if we try to go back here, uh, the first stage is iodine trapping. That is the one which involved blood iodine entering the epithelial cell through a sodium iodide symporter. Synthesis and secretion of thyroglobulin. This is a glycoprotein having over like around 140 tyrosine residues. Then we have oxidation of iodide by peroxidase in the lumen. Organification of thyroglobulin, that is iodination of tyrosine residues and the thyroglobulin. Coupling requires a peroxidase also. So that coupling we saw, we have MIT plus DIT to form a T3, or DIT plus DIT to form a T4. So storage is a storage of colloid. It can occur for several months, like 3 or more, before secretion. So let's talk more about the coupling. Thyroglobulin having tyrosine residues. Yes. This is the same. When you put one iodide, you form monoiodotyrosine. Yes. If you add a diiodotyrosine, or you can put one mono. You put two, you get DIT. So this DIT, you can combine two DITs, this one, to form T4. You can combine MIT and DIT to form T3. So T3, T4 now. This is thyroxine, and this is triiodothyronine. Okay, that is fine. That is the coupling reaction. There's no combination of MIT and MIT. So it is MIT and DIT, or DIT plus DIT. 2, 2, 4. 1, 2, 3. Okay. Let's continue. So the exocytosis I was talking about, the epithelial cells were endocytosing the colloid facilitated by megalin. Megalin is just a thyroglobulin receptor on apical surface. The reabsorption line traverses through the cytosol to the basal surface. We saw that. Proteolysis. This one was just colloid droplets which fuse with ligands. I was saying proteolysis. The colloid droplets fuse with the lysosomes. Now the proteases digest the thyroglobulin, releasing T4, T3, DIT, and MIT into cytosol. And yeah, that is what occurs in proteolysis. Now the T3 and T4 will go into the blood. By just diffusion, they can traverse through the cell membrane. Now, action of TSH. How does thyroid stimulating hormone work? Thyroid stimulating hormone exerts the following effect when it goes to the thyroid gland. 1. It increases the secretion of thyroid hormones by accelerating all the steps of biosynthesis. So it accelerates all the steps you saw: iodination, organification, like cell coupling, iodine trapping. All those ones are accelerated by the hormone. 2. It increases number and size of follicular cells, hyperplasia and hypertrophy of follicular epithelial sites. Okay, it increases the vascularity of thyroid gland. There's dilatation, blood and more blood reaches the thyroid gland. Okay, autoregulation of thyroid gland. This is important to talk about it. The secretion of thyroid gland are regulated by food iodine contents. If there is deficiency of iodine content in diet, then iodine trapping mechanism of follicular cells becomes super efficient, and the vice versa is also true. I.e., when you have excess of iodine content in food, then iodine trapping becomes less efficient, and organification of excess amount of iodine does not occur. So that is the autoregulation. As you increase the iodine blood, iodine trapping reduces or becomes less efficient. Okay? In this way, iodine availability for thyroxine synthesis remains constant. There is constant supply. It can't be too high, it can't go low. No, it is constant iodine trapping. That is the autoregulation we were talking about. Now, the mechanism of action of thyroid hormones. The thyroid hormones do not have any discrete target organ. They affect cell activity of almost all sites of the body. So they increase synthesis of enzymes and specific structure or function of proteins. This is a major point. They increase synthesis of enzymes. For this reason, you see that when you have hyperthyroidism, it means more vitamins or coenzymes will be required by the body. So you can go vitamin deficient due to only this. Okay? It increases synthesis of sodium potassiumate pairs, which means there is increased energy consumption associated with increased sodium transport. Point noted. There is increase in number and activity of mitochondria in the cells of the body. This increased rate of ATP synthesis. The hormones are responsible for increasing the basal metabolic rate. Okay? Extremely high concentration of thyronines causes uncoupling of oxidative phosphorylation process. As a result, a large amount of heat is produced, but little ATP. You recall that process of uncoupling, where we produce heat, but no ATP is, or little or no ATP is produced. Okay? Yeah, metabolism occurs, but little or no ATP is produced. Uncoupling through the ATP forming a protein. Okay, so you can find the roles of thyroid hormones in the next video, part 2 of thyroid hormones, where I talked about the roles. Don't forget subscribe for better and better videos. You share to other individuals. Share the video to also enjoy the science. Don't forget to like. These videos are very, very good and from trusted sources. You'll enjoy the videos. They are good. They are extremely good. You subscribe for better and better videos. Yeah, that's why we love you. David Seven Sun Theater. Okay, stay good. Stay good. Stay